Hello friends, so in this video we're going to be dealing with the multiplication of surds. Now there are some operations that occur when dealing with multiplication of surds. The very first case would be if you have the root of a all squared, this would always give you a. This is so because the square cancels out the square root, right? Also, if you're given a root c multiplied by b root d multiplied by b root d, what happens here is that in all cases what you do is that you multiply the numbers in front of the roots. So we're going to have a times b, then you multiply the roots with one another, right? So we're going to multiply root c times root d. So what we have now would be the root of c times d. This is what we're going to have in this case, right? So in the aftermath, what you always have in this case would be a b root c d. Also, if you are given a root c all squared, what we're going to do now is that we're going to square each of the values within the bracket. So we're going to have a square and we're going to also have root c square. Now the square cancels out the square root for the c, right? So we're going to be left with a square c. This would be our final value we're going to get. Let's play with one or two classic examples that will help drive home the point. Now we have examples. Now suppose we are given root 20 multiplied by 2 root 60 multiplied by 2 root 60 multiplied by root 48 multiplied by root 48. How do we evaluate this whole piece, right? Now in evaluating this, now we need to find two numbers whose product gives us 20. We have to simplify this root 20 now, so we have to break it down. So two numbers whose product would give us 20 would be 4 and 5, and mind you, one of these numbers must be a perfect square, right? So we're going to have root 4 times 5, 4 now being the perfect square. Also, we do the same for root 60, right? After writing down 2, we have two numbers which give us 60 now would be 4 times 15, right? So this gives us 4 times 15. How true. Now the same thing applies for root 48. So two numbers whose product gives us 48 now would be 16 times 3. So notice now that we have a perfect square in each case, right? So 4 being the perfect square in the first two cases and 16 being the perfect square in the last case, right? So the root of 16 now being 4. Now let's take the roots. The root of 4 now gives us 2. The root of 5 now, we'll have to write that as root 5. Why? Because the root of 5 is an irrational number and we cannot easily find the root. So this gives us the root of 5. So there you have 2 root 5 multiplied by, now we have 2. Now the root of 4 gives us 2 again, so this will be 2 times 2, and the root of 15 we write it the exact same way it is because that is an irrational number. So root 15 multiplied by the root of 16 gives us what? 4. Then the root of 3 now we'll write it as root 3 because that would be an irrational number. We write it in the short form. Now let's move the page and so that we can have more space to work. Now we can evaluate this now further. By doing this. I want to simplify this middle term now. So this gives us 2 times 2 here gives us 4, and we have root 15 multiplied by 4 root 3. Now what we do now is that we can multiply each of the numbers in front of our roots, right? Just like we said previously. So we have 2 times 4 times 4, let's enclose those in brackets, multiplied by the root of, now 5 times 15 times 3, we're going to enclose them within, we're going to have them within the roots, right? We're going to have them within the roots. So that will be 5 times 15 times 3. We said this earlier that all variables under roots, we multiply them together, and all variables that are in front of the root, we multiply them by one another, right? So now 2 times 4 times 4 gives us 32, multiplied by the roots now of 5 times 15 times 3 gives us 225. Now this gives us 32 times the root of 225 would be 15. 225 would be 15. So in the aftermath, 32 times 15 gives us 480. This would be our final answer. How true, how true. Let's look at another example. Also, suppose we are asked to evaluate root 24 multiplied by root 5 multiplied by root 30. Now we attempt to simplify further, right? So let's begin to simplify further. Now 24, two numbers whose product gives us 24 would be 4 and 6. So this would give us the root now of 4 times 6. How true. Now also root 5. Now root 5, we don't have two numbers whose product gives us root 5, right? So what we do in this case is that we write it the exact same way it is. Now root 30, we have two numbers whose product gives us root 30 now. So we have 2 and 15, we have 6 and 5. But notice now that among those two numbers now, 2 and 15 now, none of them is a perfect square, and among 6 and 5, none of them is a perfect square. So since we don't have any perfect square amongst those numbers, we write root 30 the exact same way it is. Now for the first case now, the root of 4 gives us 2, and here we have root 6, because root 6 now is not a perfect square, so we can't evaluate that, so write it in a short form. Now root 5 is not a perfect square, so write it in a short form. The same thing happens with root 30, such that now we can multiply all the numbers within our roots, right? So we have 2 times the root of 6 times 5 times 30, the root of 6 times 5 times 30. And in the aftermath, right, in the aftermath, we're going to have, this would give us 6 times 5 gives us 30, and 30 times 30 gives us 900. So this gives us the root now of 900. The root now of 900. Now in working this now, we have 2 times the root of 900 still gives us 30. So that would be 30, and our final answer gives us 60. This would be our final answer. How true, how true, very true. Now in the next video, right, we're going to be looking at how we can multiply compound surds, right? Very true. Thank you so much for watching. See you in the next video.